In this module, we are going to look at how NumPy works with images. And I hope you've been enjoying this course so far. Let me show you the image that we'll be working with. This is an image of a pasta. I love pasta, and I think that is why I've been biased to actually choose the image of a food. Let's head back. As we would see, I have imported two different modules that you probably have no idea about. The first one is the pillow module, which is used to work with images. And the second one is Matplotlib, which is a very known Python library that is used in data analytics and data science. I actually do have another course on this, and I would advise you take it if you are new to Matplotlib or you want to expand your knowledge of Matplotlib. Since this course is focused on NumPy, I will briefly explain what I'm doing in each line of code before we get to the NumPy area. The first thing I'm doing is loading the image using the image class from the pillow module. And I have passed in the parts of my pasta. The second thing is that I have then used this pillow representative of the image to open or to expand that image or convert that image as a NumPy array. And that is associated with this variable image array. So I just make this particular object an array by passing it into the array function. Remember, that's what we do when we are creating arrays. The next thing I've done is using the clip method to actually perform some mathematical operations on my image array. Remember that you have seen something like this from the previous section where we are multiplying an array of another shape by a scalar value, and what I'm doing essentially here is to make sure that the values, that is the pixel values of this array, is maintained between 0 to 255, and then I'm converting it into this particular data type, which is also an integer type. And then I'm using the Matplotlib to show the image. What I've done here is to basically increase the brightness by multiplying each pixel of the array, which I'm going to show us quickly.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
So this is the array, and I am multiplying this by 1.5. This means that some of the values may exceed 255. And we know that with images, the values of the pixels should be between 0 to 255, which is what I'm doing here. So that's what the clip does. We pass in the array, and then we put the values that we want to make sure that the array is clipped in. That is, it must not pass that range. And here I am using Matplotlib to basically show the brightened image. If we compare this pasta to what we saw here earlier, you can see it's like there is some brightness, although the brightness looks too bright. But this is just to show you how we work with NumPy and images. The second thing I'm going to show you is how we use NumPy to convert an image to a grayscale, that is black and white. The same thing I've done in the previous cell. I'm opening the image with the image class from pillow. I'm making it a NumPy array by passing it into the function. And this is where I then convert the image to grayscale. And one of the tricks to do that is to actually calculate it by the main function. Remember, we have treated what the main function does. And the main function, what it does is to level up the image from being a colored image to a grayscale. So it's basically go through each of the pixel in the image array as we have seen before, and then it's divided by the average, and that automatically returns the gray version of the image. And here I am using Matplotlib. If you are new to Matplotlib or you want to grow your skills better in Matplotlib, I would recommend my course Visualization with Matplotlib and Seaborn. Here I have shown the image, and as you would see here, it is looking ugly because food images should not be displayed in black and white. That is my personal opinion anyway, and this is a proof that shows that fact. Lastly, let's say we want to crop a region of interest from the image. Remember, what we are doing is basically having a bounding box, so like a rectangle, and we want to crop that rectangle from the image. We only want to extract the rectangle portion of that image. What I've done here is to create the coordinates of the rectangle, so the x1, y1, the x2, y2, and I have passed that as an index values into the image array, which is the one that we have from here. So what I've done is to use image slicing, and I'm sure you're familiar with slicing by this stage, and I'm saying slice the entire image using these regions that I've given you, and definitely that is going to crop our image. You would see it has cropped a certain portion of the image, and when we look at the original image, we know that it has come certainly from the portion of the clothes that we have on the table. I hope you've enjoyed this module. I'm going to see you in the last module, which shows you how to export and import NumPy arrays.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.